Here's my modular redstone system. This system heavily relies on these female to male pins. In order to take these pins out, I use a soldering iron. I heat up the pin and just poke it through. So I aim the soldering iron more towards the base and just heat it up gently. Once it's hot, you can just poke it straight through and it drops. Next, I grab the pin and I put it into one of the holes that I'm going to be using. Once it's in the hole, I grab the soldering iron again. From the top, I just heat it up. I just let it slowly melt. Looking on the inside, you can see that there's the header that we just melted through. And right here, you can see the outside. Trying to move this header, it's pretty melted in there. Like, it won't move around. Now, if I open this up, you can see that there's a header going into the top pins. So just pulling that off, out comes one of the modules that I made, detects light. Or if I change these two wires, swap the red and the black, and so now instead of detecting light, it'll detect darkness. This module here is just being powered by a 3-volt coin cell. On the bottom of this module here, it has two headers that connect down into the bottom that come out through here. In order for the circuit to work, it needs the photoresistor to be connected here, and now it can detect light or darkness through there. Here's a circuit for the light detection or darkness detection. Basically, it's creating a voltage divider here that powers a MOSFET and allows current to flow through the diode. Right here is a switch. And so depending on how I connect the circuit will determine whether or not it detects darkness or brightness. If you have any questions on how it works, I've made 2 videos on this daylight sensor, which uses the same circuit, so you can check those out. I go into more detail on how the voltage divider works. Again, in order to connect any wires to the outside pins, it's easiest to solder the wires onto the headers and then connect the header onto the header that's connected to the body. So for example, right here, I have the top, which is just 2 headers. And so this makes a connection here, and it's able to close up. And so now if I open it up and I need to change the module, all I need to do is disconnect here, pop out the module, and then put in a new module. I don't recommend trying to solder these wires straight onto the outside headers that go into the body, because it's enough heat to melt the plastic and move the headers around. So instead, melt the wire before onto a separate header that is used to connect onto the body header. On the inside of this one, I have 3 AAA batteries, the total being 3.6 volt. It's separate from the main body and it's just been wedged in. The system has 2 sets of headers. Originally, the 2 sets were added since the bottom set was mostly just for these torches. The second set I added in order to make the lever work, as well as this button. Moving forward, it's necessary for both these sets to exist. If I'm trying to power, for example, a piston back here, this bottom set will work as a power. So it can have 5 volts going through and a grounding pin here. The top set will work as a signal or a data transmission line. That means when powering this piston, which uses a servo along with a microcontroller, the bottom set of pins will supply the power. The top pin will send a signal to the microcontroller telling it if the block is in a powered state or if it's not in a powered state. It'd also be nice to have magnets that allow the blocks to click into place. I've also updated the design of how these boxes lock into each other. I added a little ridge on the inside of the boxes and also an overhang on 2 opposing flaps here on the top. So now when it locks in place, it has a harder time coming out until you get right underneath it. In order to make the block with the redstone dust on top, I just have this LED with the 100 ohm resistor hooked up. I just press it down, snap the top on, then send it a signal. Right here I've made tops for redstone, and this is the flattest I could make the redstone. On the inside is resin that's been dyed, just using some eyeshadow mixed into the resin. And on the back, I've used packing tape. It did a decent job, but you can still see that a lot of it leaked through. The top, however, came out pretty nice. Previously, I made this design here, which used copper foil tape. Trying to make the redstone out of this copper foil tape is pretty tough, and trying to solder these LEDs onto the foil tape was also a little difficult. I also had to use a current limiting resistor here. I think this one is a 1000 ohm resistor because at the time it was being powered by 5 volts, so it needed a higher resistance to limit the current. Right here I have an example of a redstone signal. As you can see, as I increase voltage, they individually light up. This is using Schottky diodes, which have a really low voltage drop. All these resistors here in order to limit the current. This is a really simple way to emulate the redstone mechanics. So using this design, I'm able to just connect these blocks together. With a voltage of 5, it's able to power 15 LEDs. The redstone torch is printed in 2 parts, one being the cap here that I printed out of red PETG, and the main body here, and so it just presses on. On the inside there's a 3mm red LED. Taking it out, it has a 100 ohm resistor soldered right on to limit the current. These LEDs operate at 1.6 to 2 volts, and anything above 2 volts will burn out the LED unless you limit the current. These leads I've had to extend. I also recommend wrapping the leads in electric tape before putting through the body. If the leads happen to cross, you'll create a short circuit and it'll damage the battery. If you're using any lithium polymer batteries, this can make the battery explode, so you need to be extremely careful. The side torch is a different model, which just has this cutout here that allows it to be at the angle. Here's a button I printed a while back, and on the inside I just attached a tactile button here, again using some resin. I also added these leads on the back here that can connect into the headers. Currently I don't have an inverting circuit in order to make the torches turn off when the button is pressed, so right here it's reversed. The lever is a quick solution since you just invert the lever and you can have the functionality. Here's the inside of the lever. So it has 2 pads on each side. The lever itself has 1 small pad. So if it's connected, it will turn on the circuit. I'll be making a separate video on this button and the lever, improving the design and adding the inverting circuit. So that's my modular system at the moment. If you have any questions, please let me know, and thank you for watching.